Okay, so now we're looking at completing the square. I'm going to do exercise, question 9F first. So it specifically tells us to complete the square and then sketch. So we're going to start off by completing the square and then we're going to do the normal process. So complete the square. Now, this one's still a monic, so the number in front of the x squared is still like there's nothing, it's just 1. So we've got y equals x squared, take 3x plus 4. And don't forget, whenever you're completing the square, you're doing stuff to these first ones and then making up for it. So the first step we always do is, in brackets, we just do our x, and then here we're going to do minus 3 over 2. Now, the reason I had to do 3 over 2 was because I'm now squaring it. When I expand that squared, it's x squared take 2x plus a squared take 2ab plus b squared. We have to do the over 2 to compensate for that. But this means we're going to end up with positive 3 on 2 all squared afterwards when what I want is positive 4. So I have to minus 3 on 2 all squared, and then that plus 4 goes on at the end. So just to show you where things come from, this plus 4 is happy at the end. This minus 3 became minus 3 here. That 2 on the bottom is always there. And this second one, that minus 3 on 2 all squared, is always going to be a minus. Don't worry about the sign of that. It's always going to be a minus. So for this one, I've got x take 3 on 2 all squared. Minus 3 on 2 all squared is negative 9 on 4 plus 4, which comes out as y equals x take 3 on 2 all squared plus 7 on 4. Now, it says to then sketch showing the vertex and intercepts with the axes. Don't forget, and before we do this, I'm just going to point out that this is in the same form as y equals a outside of x take h squared plus k, where h and k, this is the axis of symmetry, and this is the y coordinate of the turning point. So the rest of our job is going to be slightly easier than usual. So y-intercept, let x equals 0 as usual. You could do this in the completed square version of the formula, or you could do this in the x squared take 3x plus 4. I'm going to do that. So I've got 0 squared take 3 times 0 plus 4. It's going to come out as 4. If I'd done it in the other one, I would have had 0 take 3 on 2 all squared plus 7 on 4. Which hopefully would have come out as 4. Yeah, should have. Okay. So x-intercept let y equals 0. Let's have a look, and I'm going to leave everything in surd form. So I've got 0 equals x take 3 on 2 all squared plus 7 on 4. I'm going to take this 7 on 4 over to the other side. I'm going to get negative 7 on 4 equals, am I sure that's going to be 7? Yeah. X take 3 on 2 all squared. Now I want to square root, but I can't square root. Can't square root a negative. Therefore, no x-intercepts. Whole thing happens above or below the x-axis. You know what I forgot to do first? I forgot to actually find the concavity. I repeatedly forget to do this. Concave. The concavity here, there's no negative in front of the x squared, it's a positive. Which means this whole thing's going to be above the x-axis, by the way. Okay, now, axis of symmetry. Here we don't have to add our x-intercepts or anything. We know straight away, well, it's just as well because we can't actually add x-intercepts when there are none. We don't have to find halfway between our x-intercepts. Here we know that the axis of symmetry is just whatever's minused in this bracket. So x equals 3 on 2. And the y-coordinate, we could either sub x equals 3 on 2 into the equation, or we can just take the last number. Either way, it's going to come out as y equals 7 on 4. Okay. Now we sketch. I'm going to change my paper to grid paper. This is not going to be too accurate, by the way. Once we start to get fractions, I start to get like not accurate at all. Oh, come on. I do like to do straight lines though. There we are. There we are. Now, my y-intercept is 7 on 4. The axis of symmetry is 3 on 2. Oh, it's not 7 on 4, it's actually just 4. Gosh. 4, it's going to go through there. The y-coordinate of it is 7 on 4, which is a bit less than 2. So it's going to turn here. That's all I need to know. Yep, that's about what it looks like. And I need to label my axes, y and x. Okay, question 10 says, explain why y equals a outside of x plus 4 all squared plus 2 is the general form of quadratic with vertex minus 4 and 2. So let's have a look. 10. So we've got y equals a x plus 4 squared plus 2. So h is minus 4, k is positive 2, axis of symmetry is x equals minus 4, the y-coordinate is positive 2. The reason it's the general form is because this a out the front is going to determine how fat or thin it is, but all of them are going to have that turning point. So if I was to draw some generic ones, y, x, negative 4, 2, so that's the turning point. So it's going to have like really thin ones or really fat ones, sad ones, happy ones. All of them like the value of a is going to change the shape of it, but they're all going to turn at that point negative 4, 2. Okay, then find the equation of such a quadratic for which the quadratic is monic. So if I have 10a, so we've got y equals a outside of x plus 4 squared plus 2. Monic means that a is either positive 1 or a is negative 1. So the equation is literally just x plus 4 squared plus 2 or negative x plus 4 squared plus 2. That's it. Question B says the coefficient of x squared is 3. 10b. Well, a is the coefficient of x squared. So here, a equals 3. So we've got y equals 3 outside of x plus 4 squared plus 2. That's it. 10c, a little bit harder. We know for the y-intercept is 16 when x equals 0. So now we're actually going to have to solve this thing. 16 equals a outside of 0 plus 4 squared plus 2. So 16 is a times 4 squared is 16 plus 2. So subtract 2 off, that's 14 equals a times 16. So a is actually 14 over 16, which is 7/8. So y equals 7/8 outside of x plus 4 squared plus 2. And the last one is the curve passes through the origin. Oh, this one's a teeny bit easier. 10D, hopefully. Origin. So it's going to go where an x is 0, y equals 0. It goes straight through the point 0, 0. So it goes through. Yeah. So we have, well, we're going to have 0 equals a outside of 0 plus 4 squared plus 2. Take the 2 over, I've got negative 2 equals a times 4 squared is 16. So a is actually negative 2 on 16, which is 1 on 8. So we get y equals negative 1 on 8 x plus 4 squared plus 2. So the value in front of the x, take h all squared plus k, the value out the front of the brackets, tells you a lot about the shape of it, but the 4 and the 2 always means it turns around at that point. Alright,